Aí, naquele oportunidade aí, né?
Good morning, students. Good morning, students. Good morning, students. Good morning, students.
Oh, good morning.
Good morning.
Good morning.
Oh,
Good morning.
Good morning.
Good morning.
Good morning.
Yeah. Good morning.
Good morning.
sorry, we've been having the challenge of the network, but now it is working.
Oh,
So
good morning.
we are going to start, and we shall go through KCC 2018, paper 1. So we are going to start with the first question. So again, before we start, it is good for us to stick to the rules. For example, those students who have not used their two official names, in the next 5 minutes, I'm going to remove you from the group. So I'm giving you only 5 minutes. You write your two full names so that we can proceed. So now we can start with question number 1. State a reason why an object on Earth has a higher weight than on the moon. State a reason why an object on Earth has a higher weight than on the moon. State a reason. Paul Gabogo, I can see you are raising your hand. Paul Gabogo. State a reason why an object on Earth has a higher weight than on the moon. Gilbert Kamau.
This is because the Earth's gravity is much larger than the moon's.
The gravitational pull on the Earth is much higher than that on the moon. We go to question number 2. The figure 1 shows position of a student's eye while measuring the length of a wooden block using a meter rule. Determine the length of the block as viewed by the student. So you can see the eye position of the students. It is not perpendicular to the reading, so it has some parallax error. So because the question is as viewed by the student, this student from this position, they can be able to see this point, and we can see this is 6.0. Being a meter rule, it has accuracy of 1 decimal point, so this 6.0, not 6. Then this one, the student will be able to see this reading, which is going to be 7.3. Therefore, it will be 7.3 minus 6.0. So in this kind of a case, you have to show the working. Even if it is awarding 1 mark, you have to show the working so that you can qualify to get the 2 marks. So in this case, what we can do, we just write down 7.0, you subtract, 7.3. 7.3, you subtract 6.0. So you have to show your 6.0. So whatever you are going to get now becomes the answer, which is going to be 1.3. Don't forget to write the units, because the units qualify. Will make it not writing the units, you might be denied a mark. We now move to the next question. Describe how the knowledge of the oil drop experiment may be used to estimate the area of oil spillage from a ship in the sea, assuming the surface water is not disturbed. So how can we determine, assuming the surface water is not being disturbed? So in this case, these are topic in Form 2, measurements 2, that is oil drop experiment. And we want to estimate the area of oil spillage from a ship. First of all, that ship, before it spills oil, already you know its volume. If you know the volume of the oil in the ship, but you don't know the area that it can spread to, suppose we assume that this ship, the oil it is carrying, it is 1 million cubic meters. So suppose we say it is 1 million cubic meter. It is an assumption. So 1 million cubic meter. Suppose you want to get the extent of surface that it is going to spread. You don't know, because the question is asking that may be used to estimate the area. So what you're going to do, you just scoop some little amount of oil of a known volume, maybe using a container of a known volume. Let's say your container is of 0.5 cubic meter. This 0.5 cubic meter, being just a little amount of oil, you can pour it on the surface of the water. You check the extent of the spread. Maybe it is going to occupy, let's say, 20 cubic square centimeters, or 2,000 square centimeters. You ask yourself, what about 1 million? 1 million is going to spread to what extent? So you just write your 1 million is going to spread to what extent? So you do cross multiplication and you get the answer. So the whole of this narrative is the one that you're supposed to put it in writing, whereby you have to state that you scoop a known volume of oil, spread it or pour it on the surface of the water, check the extent of spread. Then you do the comparison. What about the total volume of the oil that was in that ship, how it is going to spread? So that is the only way that you can deal with such nature of a question. We move to the next question. So in our next question, sorry, let me erase this one. So in our next question, the figure shows an instrument used to measure atmospheric pressure. State with the reason the modification that will be required in a similar setup if mercury were to be replaced with water. So what modification do you think we can do? Modification, so that instead of using the mercury, as you can be able to see from the nature of the meniscus, we now decide to use water. One modification that you can use. Yes, Mark Moutier, you have an idea? One modification. Brian McCory.
Using a longer tube.
Using a longer tube. Reason?
Water occupies a longer column than mercury.
Yes, why does it occupy a longer column? That reason is the one we want to know. Why does it occupy a longer column? Because it has what? Because it has, yes, Sami Moshiri.
Water has a lower density than mercury.
That is it. Water has a lower density than that of mercury. So you use a longer tube because water will occupy a longer column since it has a lower density than that of mercury. We move to the next question. It is observed that a drop of milk carefully put into a cup of water turns the water white after some time. State the reason for this observation. state the reason for this observation. Let's have a volunteer. A volunteer. Benjamin Monia. Benjamin.
Yes.
Why do you think that a drop of milk carefully put into a cup of water turns water white after some time?
Because of diffusion.
Because of diffusion, and you go ahead to explain that milk particles get in between the water particles. So that is diffusion. We move on to the next. The figure 3 shows the shape of a bimetallic strip after it was cooled below room temperature. Explain why the strip curved as shown. Point to notes cooled below room temperature. Cooled below room temperature. Why do you think this strip curved? As we can be able to see, we have one side of brass, the other one of inver. Again, I'm reminding those two students who are not using the year 2 official names. I'm about to remove you from the group. Yes, someone to explain. Justin Kibet.
Yes.
Justin Kibet. Justin Kibet. Let's have a volunteer. Okay. Yes, Frederick Mogo. Frederick? Frederick Mogo. You can see Frederick, we are not communicating. Frederick Mogo. Okay. So when you cool it, this is the shape it is obtaining. Gidiaka, just say you have something to say? Gidiaka? Gidiaka, can you hear me? Okay. First of all, this brass at this position, because it is the shorter one than inver on cooling, it means that it contracted more, meaning that brass has a higher linear expansivity. So the first mark is to state that brass has a higher linear expansivity. It has a higher linear expansivity, and that is why it is able to contract more. So when it is contracting more, then it is going to show that kind of shape that we are able to see. So that is what was supposed to be there. So this part to award the first mark, then the second one to award you the second mark. We'll move on to the next question. Number 7, we have not covered. It is in a Form 4 topic. So number 8, Form 4 topic. We move to question number 9. Figure 5 shows a ball spinning as it moves. On the diagram, sketch the path followed by the ball as it rises. Sketch the path followed by the ball as it rises. We can see that the ball is moving towards this direction, but this is the direction of spinning in anti-clockwise direction. Is this ball going to move upwards or downwards? Can we have an answer? Is it upwards or downwards as it is spinning? Yes, Ami Moshiri?
Upwards.
Upwards. So it is going to move upwards. Therefore, the direction of movement is going to be this way. That is the path followed, and you get 1 mark. Then explain why the ball takes that path. As this ball is moving, remember that the air is blowing in opposite direction. So when the air is blowing in the opposite direction, at the top, the ball is spinning this direction. it is the same direction the air is moving. So it means that the speed of air is going to be increased because it is being pushed in the same direction by the spinning of the ball, spinning effect of the ball. Therefore, at this position, speed of the air is higher, so there is lower pressure. On the lower side, the air is moving towards this direction, but the spinning of the ball is moving in opposite direction. So it means that the air speed is going to be reduced. So there is reduced speed of air, which results to higher pressure. So this higher pressure results to what we refer as lift. It is going to provide a lift because the region of higher pressure, this one of lower pressure, will now push this ball to move upwards, giving the dynamic lift. So that is how we can tackle such kind of a question. We now move to the next. Number 10 we have not covered. Number 11 is our next question. So the figure below shows an L-shaped wooden structure. On the diagram, construct an appropriate lines to show the position of the center of gravity of the structure. It is good as you keep on revising, you'll be checking the textbooks and whatever they have. For example, this is a diagram that is in KLB book 2, the exact diagram as it is. So what you're supposed to do, you have two solids which are rectangular in shape. You get the position of the center of gravity of each. So for example, to get this one, definitely we are going to put a diagonal line, and these diagonal lines, where they meet, that is the position of the center of gravity of the whole of this lamina here. Then for this one, we'll repeat the same exercise like that. This is the position of the center of gravity. Now, the position of the center of gravity of this one being here and this one being here, it means that the resultant position of the center of gravity for the two around this position in between the two COGs. Therefore, join the two using a straight line like that. Then from here, draw a line that will touch this edge and move on. So this position is where we have now our center of gravity. So our position of COG, here it is. So that is what was expected of you. We move on to the next. On the figure below shows, just 1 minute. The figure below shows a graph of extension against force for a certain helical spring. On the same diagram, sketch a graph of extension against a force for a spring with the lower value of the spring constant. So a spring with the lower value of constant, spring constant, do you expect it to extend more or less? That is what we need to ask ourselves. Such kind of a spring, for just a little amount of force, it extends more. If it extends more, then it means that if you are to sketch for just a little amount of force, the extension is going to be higher. So it means that this is a line that will pass across this side such that a small force from here to here results to a higher extension from here up to here. So this is the line that was required. We now move to the next question, that is question number 13. State two ways in which a mercury-based thermometer can be modified to read very small temperature changes. Two ways in which a mercury-based thermometer can be modified to measure very small temperature changes. So one, let's have one. Yes, Dean Jenga?
Having a thin bulb so that you can detect minute temperature changes.
That is it, but make sure you use comparative language. Thinner bulb, not thin. Using thinner bulb. Or using thinner bulb. Another one? Another one? Jenga, you still want to attempt?
Using thinner glass.
Using a thinner bore. Don't talk about glass tube unless you talk about a thinner inner part of the tube. Using a thinner bore is the other one. Then number 14 we have not covered. We go to question number 15. State Newton's first law of motion. Newton's first law of motion. Newton's first law of motion. Ken Warui.
It states that an object remains in its state of rest unless acted by an external force.
You have an idea, but not complete. A body remains at rest or in motion. So it remains at rest or in motion unless acted upon by an external force. We now move to question number B. A wooden block resting on a horizontal bench is given an initial velocity u, so as it slides on a bench for a distance x before it stops. Various values of x are measured for different values of the initial velocity. Figure 9 shows a graph of u squared, this is u squared against x. This is x. Determine the slope s of the graph. So do the calculation. Find the slope of the graph. Find the slope of the graph. Find the slope of the graph. Once you're through, just lift up your hand. So you are through, Ted. Ted Mbiduka, you are through. Rogers, you are through. Morris, are you through? Morris Rogers, Roy Mwenda. We are getting the slope. Okay. I think we can work on it. Enough time. We want to get the slope. The first thing for you as a student to do, identify some points that you'll be able to use. For example, along the line, we just mark, I have this point here. Write down the coordinates of these points. And we can be able to see that the coordinates here, this is 5, 6, 7, 8, 9. So this point is 9 against 50. So that is the coordinate of the point. Having this coordinate, I can take another coordinate like this one, and we can see that the coordinate here is 0, 0. So with 9, 50, and 0, 0, we now move on to get the slope. And you know that the slope is equal to change in y, and in this case, it's change in u squared. So here the change in y-axis is u squared. So we write down change in u squared over change in this side. You can see that we have x, so change in x. So in this case, our slope is going to be, my u squared here is 50 minus 0. So I'll just write down 50 minus 0, the whole of it over, so the whole of it over change in x. This is 9 minus 0. So in this case, we are having 9
It should be
minus
8. 8.
Oh yeah, sorry. 8 minus 0. Thank you for that correction. So this point here is 8, not 9. So in that case, then it means we are left with 50 over 8. So 50 divided by 8, we get what? Is it 6.75? 6.25. So our final answer here, we are going to have 6.25. So that becomes our answer. And now we can move to the next. The next question, determine the value of, there was a mistake in this question I want to correct. This value was supposed to be kx. So it was supposed to be u squared is equals 20kx. So determine the value of k given that u squared is equals to 20kx, where k is a frictional constant for the surface. So we have to determine the value of k. So just 1 minute, I want to erase the unwanted bits. So far, at least we know that u, or I mean the slope s, we got 6.25. We are going to use that knowledge so that you can be able to manipulate to get this value. Our graph is u against u squared against x. So that one, from the look, we can see that it is already in the format y is equals to mx plus c. C is 0, c is y-intercept, and because y-intercept is 0, then this one is equals to 0. Y-axis is u squared, this one. So this is the value of y-axis. X-axis, remember this is x. X-axis is this one. So m represents 20k, and remember m is the slope. Therefore, for you as a student, that moment you are going to show that slope is equals to 20k. Already you have an idea. Showing the examiner that slope, your slope is equals to 20k. That is where your first mark is going to be awarded. Then the next thing you work out, your slope we can have 6.25 is equals to 20k. So you work out to get the value of k. That is going to be 6.25 divided by 20. So, and you get 0.3125. Therefore, it implies that your k is equals 0.3125. And that becomes your final answer. We move on. State the reason, with a reason, what happens to the value of k when the roughness of the surface is reduced. When the roughness of the surface is going to be reduced. So, just 1 minute. Okay. This is the graph of u squared against x squared. U is velocity. When you reduce the roughness of the surface, it means you're making the surface to be very smooth. When you make it to be very smooth and you allow this ball to move, then you find that it is going to move at a higher velocity. So this side is going to increase more. And that means that the graph will move towards this direction. So that graph is very steep, meaning it has a greater slope. So the slope is going to be higher. So this slope, the moment it increases 20K, or this 20K, you make it increase. I mean, you make, sorry, the slope, the moment it will increase, and it is at the moment is 6.25. If I increase this one, then you divide by 20, an increased value of numerator, then it's also increasing. Therefore, if we come to this question, the value of K increases because the slope is going to increase. Then we move to question number C. An object is thrown vertically upwards with an initial velocity of 30 meters per second. Determine its maximum height. So work it out. Determine the maximum height. Just work it out so we see what you're going to have. Once you are through, you can lift the hands. Melchizedek, Moira, are you through?
Yes.
What answer are you getting? Pardon? 5.
45.
5, okay. Someone else? Gilbert, come on, what are you getting?
45 meters.
45 meters.
45.
Okay. 45. Frederick Mogo, what are you getting? Frederick Mogo. 45. Okay. Majority of you are getting 45. Let's see. An object is thrown vertically upwards with an initial velocity of 30. So already we have initial velocity u being equal to 30. Then determines maximum height. The height that it is going to reach, you don't know this height. So this height is the one that we want to get. When you throw an object to move upwards, it is moving against the gravitational acceleration. So the acceleration becomes negative of 10. So we still move on. This object, while you throw it upwards at maximum height, velocity is going to be 0. So the final velocity v is equals to 0. With all these quantities, you now ask yourself, which formula has all this? So this formula that has all this is v squared. The formula is v squared is equals to u squared plus 2as. So with that in mind, then it implies that we are going to have this squared, which is 0 squared. 0 squared is equals to u squared 30 squared plus 2, a is negative 10. Negative 10 multiplied by s. So 0 is equals to 900 minus 20s. So in this case, bring this to the other side. And once you do it, it now becomes positive 20s is equals to 900. So from there, it implies that our s finally is equals to 45 meters per 45 meters. So that is going to be the final answer to that question. So we can now move to the next. Number 16. This is still another question that had some error, but I'm going to correct you. An electric crane uses 8.0 times 10 to the power 4 joules. So this part is joules, not newtons of energy. The units of energy is joules. So it contains 8.0 times 10 to the power 4 joules of energy to lift a load of 2.0 times 10 to the power 4 newtons in 4 seconds. Determine the power developed by the crane. So do the calculation, get the power developed by the crane. Work it out.
Jesus.
Yes, Ferdinand Kabila, what are you getting?
20 kilowatts.
20 kilowatts. Let's see. So we know power is equals to work done over time. And from what you can see, the power of the work done in this case is 8.0 times 10 to the power 4. So 8 times 10 to the power 4. We are dividing the whole of this by time of 4 seconds. So 8 divided by 4, that is 2. So it will be 2 times 10 to the power 4 watts, or whatever Ferdinand has told us, 20 kilowatts. So that becomes our final answer. Then the next question, the height to which the load is lifted. Determine the height to which the load is lifted. The height to which the load is lifted. Work it out. I'm waiting for your answer. Yes, Sami Moshiri.
4 meters.
4 meters. Do you have some other students who are still getting the same answer as 4 meters? Are there students still getting 4 meters?
Yes.
Are there students getting 4 meters? Okay, let's see. The height to which the load is lifted. We know work done, or in short, because we want to get height, work done is equals to force multiplied by the distance. If this is the case, already the amount of energy is this one, which is equivalent to the work done. Therefore, it is 8 times 10 to the power 4, which is the same as 80,000, is equals to the force is this load of 20,000. So 20,000 multiplied by the distance that we don't know S. So dividing every side by S, we are going now to get our S 4 meters. Then we move to the next question. Efficiency of the crane whose motor is rated 2.5 times 10 to the power 4 watts. Efficiency of the crane, work it out. Efficiency of the motor. Yes, Sami Moshiri.
80%.
80%. Let's see what we are going to have. In order for us to be able to get the efficiency is usually work outputs over work inputs. So here efficiency is equals to work outputs. So this is work outputs. You are dividing the whole of this by work inputs. So work inputs, and then the whole of this you are multiplying by 100%. So all this is the one that now you are supposed to work it out. So we can see the amount of work it can be able to do the crane. This is the output. Sorry. The work done in this case is this one. And the motor work input is this one. And it is giving sorry. This is not, let us work in terms of power. I'm sorry for that. So it is the power outputs over the power inputs. So this is power inputs. Power outputs, here it is 20. So this 20, we are dividing by the power output of 25 kilowatts. 2.5 times 10 to the power 4 is 25 kilowatts. So we just divide by 25. Then you multiply by 100%. And whatever we are going to have, it is equal to 80%. So that is going to be our answer. Then we move to the next question. State two forms of energy transformation that lead to cranes inefficiency. Two forms of energy transformation. One, some of the energy is wasted in which form?
Friction.
Yes, Kavila. Someone has said friction. Frictional force between the moving parts. The other one?
Heat energy.
Heat energy is another one. There is heat energy. Also, energy wasted in lifting the movable parts. So those are the ways in which some of the energy has been wasted in such kind of context. We'll move on to the next. Let me check whether you have a question that you can manage as form phrase. Yeah. Part B. A stone is dropped from top of a building to the ground. On the axis provided, sketch a graph of potential energy against the stone, against time for the stone, that is. So when this stone is at the top, the potential energy is maximum. And we are told graph of potential energy against time for the stone. So this as the stone is moving downwards because it has been dropped, it will start losing potential energy as the time is increasing. Therefore, in such kind of a case, then we expect the graph to be drawn to show that potential energy is moving from maximum, reducing all the way up to 0 as the time is increasing. So that is the nature of the graph that was required. Let's see whether we still have another question that we can manage, which was done in 2018. Yes, we have this one. State Pascal's principle of pressure transmission in liquids. Pascal's principle. Pascal's principle. Pascal's principle. Pascal's principle. Sami Mushiri.
Pressure at one point in a liquid is transmitted equally to all other parts of the enclosed liquid.
That is it. Pressure in an enclosed liquid is transmitted equally in all directions. Pressure in an enclosed liquid is transmitted equally in all directions. This question, a condition that was there, it is liquids. So you are not supposed to use fluid in that case. So you have to be sensitive about the nature of the question that has been brought to you. Figure 10 shows heights of two immiscible liquids X and Y in a U-tube. Liquid X and we have liquid Y. State with a reason which of the two liquids X and Y has a higher density. Between X and Y has a higher density. Which one do you think it has a higher density between X and Y?
Y.
Y is wrong. It is X. Because for once it is occupying the lower side, meaning it is more heavier. Then again, you find that its height is shorter. So from the mean position, this height being shorter, then it means X. It has a higher density. Then you move to question Roman 2. Determine the value of H. So the value of H, this one, the densities are not given. But now the question has a trick. Note this part, drawn to scale. So in this case, the students were supposed to use a meter rule to measure. So you are supposed to take a rule, measure this distance. For example, this distance, suppose you measure it and you get, let's say 3.6 centimeters. I'm just guiding you on how it was being worked out. If it was 3.6 centimeters, we can see 3.6 centimeters, it was occupying 20 centimeters. There. So it was occupying 20 centimeters. Then you take again a ruler, measure this one. Suppose you measure with a ruler and you get centimeters. You ask yourself, 2 centimeters will be value of it. So from here, do cross multiplication and whatever you get becomes the value of H. This one, there was no other formula that was being used because the examiner wanted to check whether you have an idea of going. Move on. Let's see whether you have another question of this level. Given that the density of liquid Y is raw, density of P, then you are supposed to use this concept here. You can try to work it out. For now, I may not work it out because I cannot be able to measure with a ruler. So I check whether we have some other. You can see that we don't have. So that marks the end of our lesson. So thank you very much again for your participation. Have a nice day.
Thank you.
Thank you.
Thank you.
You're welcome.
Thank you very much.
Thank you.
I thank you.
Okay, bye. Bro.
Thank you so much.
Bye.
Thank you.
Good morning.